please. The October 2022 Recreational Astronomy Night Meeting online edition of the RAFC Toronto Centre. My name is Paul Markov, coming to you from Markham, Ontario. And before I continue, I would like to mention a personal milestone tonight, since this audience, I think, is the only one who would care to hear about it. I joined the Toronto Centre 40 years ago in October of 1982, when I attended my first members' night meeting at the McLaughlin Planetarium. And I enjoyed those meetings so much that I've been hosting them for the past 20 years. And as such, I'm always looking for speakers for our meetings. If you would like to present or know anyone who could present, please get in touch with me. We have openings for the December and later meetings. And our meetings are held on the first Wednesday of each month. Before we start the presentations, I'd like to recognize our top-notch technical team comprised of Andrew and Betty Reed, Ward LeGros, and Ennio Ciolucci. Thank you for making these presentations possible for us tonight. We have 3 presentations as usual, and I expect to be done around 9:30. The presenters are Andy Beaton, presenting the sky this month, followed by Francois van Heerden, and he'll talk to us about test driving the ToupTek 20 megapixel camera. And then we have one of our youngest speakers ever, Arushi Nath. She'll present to us about photometric observations of the Didymos asteroid system before the impact, using robotic telescopes, open datasets, and math. Tom Luton, our president, will close the meeting with announcements as usual. If you have any questions for our speakers, please enter them in the YouTube chat box, and Ennio will ask the speakers your questions. And if you are attending the meeting for the first time, whether you're a member or not, please say hello also through the YouTube chat box and let us know where you're from. So I think we're ready to get the presentation started with Andy Beaton and the sky this month.
Hi, my name is Andy Beaton. I'm speaking to you from my basement office in downtown Toronto, and bring greetings from all the spiders and centipedes that have moved into my office now that the cold weather's here. I just want to say congratulations to Paul. 40 years is a pretty good run. I was there for some of the 1982 meetings, my first year in astronomy class at U of T. I didn't stay long because soon I had a lot of math problem sets and no time for fun, but we were there for a while. Anyway, here we are, the sky this month for October 5th until the next meeting, I think November 3rd. As usual, I've got a list of stuff to go through, the big picture of what's up in the sky, key dates, the moon, the planets, something going on in the deep sky, an interesting double star, obviously an interesting variable star because that's my thing, and then whatever is coming up in the world in space flight. It's particularly interesting. So starting with the big picture, if we go out tonight around 10 p.m., this is what we're seeing. And the exciting stuff is obviously the big parade of planets. We've got some really nice planets showing up there, Saturn, Jupiter. We've got Neptune, Uranus will be along, and a few minor planets if you happen to have a really good telescope and a really nice dark sky. The moon is up. It's going to be a nice night for looking at the moon. It's one of those phases where you get a lot of interesting stuff happening along the terminator. By the end of the month, we're going to start seeing the spring constellations show up in the morning. We've got Cancer and Leo there. We'll have Mars well overhead. Our winter constellations will already be starting to drift off towards the west, but there will be some good stuff to see there. You'll have a chance to see all your favorite winter constellations, Orion and Gemini and all that good stuff. Now, because this is October, we've got Halloween coming up. Normally, I don't really pay too much attention to holidays during this presentation, but I'm going to point out what's coming up on Halloween around 7 p.m. because it's always fun, if the weather is clear, to take telescopes out, put them on the sidewalk, and show some stuff to the kids going by. And this is going to be a good year for that, weather permitting, because we've not only got two big planets, Jupiter and Saturn, out there, but we also have the moon, which is something that is easy for the kids to see. They'll be able to figure out what they're looking at. It doesn't take a lot of astronomy knowledge to show a kid the moon and have them get pretty excited by how much fun it looks in a telescope. So our nights are getting longer. They're colder, but the good news is more dark skies at night for us. Astronomical twilight ending around 8:10 tonight, starts again at 5:25 in the morning. By the next meeting, well, twilight finished at 7:30 and starting again at 6 in the morning. So that's a good long night of observing. Important stuff coming up. The new moon on October 26th. The moon at apogee on the 17th and perigee on October 29th. Full moon on October 8th. So prepare your videos of good movies to watch while your deep sky observing is ruined. We've got a partial solar eclipse coming on October 25th. It's only visible in Africa and Europe. We're not going to see it, but due to the power of the internet, we may be able to watch it on screen, or you may be watching this from Africa or Europe and actually have an opportunity to see it yourselves. And we have Uranus being occulted by the moon on October 12th. That should be clearly visible for us around here in Toronto or most of North America. So if we get a clear sky, it'll be worth going out and looking for it. The moon, first quarter on November 1st, the full moon on the 9th, last quarter on the 17th, and the new moon on October 25th, just about a week before Halloween. So we'll have a few days for the moon to reappear in time to impress the public. The lunar X, for those who don't know, if you take a couple of craters and kind of put them side by side, the crater rims form an X when they're lit up by a certain angle. And that happens at 3:18 in the morning on November 1st. I wouldn't get up at 3 in the morning to see the lunar X. It's a cool thing to see. It's not really scientifically important. But if you're up at 3:18 pursuing what other astronomical projects you've got going, then yeah, I would absolutely take a few minutes and point your telescope that way and have a look. It's a pretty neat looking phenomena. So we have a flood of planets, obviously, for the first week of October, peaking on the 9th. This is going to be the best time of the month to look at Mercury. This is early in the morning. Venus is going to be too close to the sun. We're not going to have a look at it this month. We're just going to have to wait for that one. But this is a really good time to see Mars. It's rising around 10:30 tonight and earlier throughout the month. And it's getting bigger and bigger as it gets closer. Last time I saw Mars back in the spring, it was about 3 or 4 arc seconds across. Now it's 13 to 15 arc seconds across. It's noticeably disk-sized in your telescope's view. You should be able to start seeing features on the surface, at least the ice caps and maybe some of the big dark blotchy bits. And Saturn and Jupiter are going to be the stars of the sky for the next month. Jupiter is up all night, and we just passed opposition a few days ago. So this is as big and bright as Jupiter is going to be. You should be able to see it just about anywhere. It's unmissable. It's insanely bright. You will look up in the sky and it will catch your eye like nothing else. Saturn is ahead of Jupiter in the sky. It'll set much earlier, but it's also well up in the sky in the evening when most of us are out with our friends in our telescopes. And as always, it's just about the most spectacular thing in the sky. You know, everybody loves seeing the rings. Uranus and Neptune, the ice giants, are also very well placed this month. Um, Uranus will be up all night long. It's in Aries, and it's going to be approaching opposition, not quite there in this month, but it is going to be very bright. It's going to have as large as it's going to get. Not that there are ever really any features that we're going to be able to see with our amateur telescopes, but this is the best view we're going to get of it for a while. It'll at least be big enough that if you're showing it off to your friends, they will look at it through a telescope and they will see a disk, and it will be clear that it is not a planet, or sorry, not a star, but an actual planet. Same sort of deal for Neptune. It's just past opposition in Aquarius. It's going to be dimmer. You're not going to get it at naked eye brightness, but you're still going to get a visible disk and that distinctive bluey green color that everybody loves the ice giants for. And then we have the dwarf planets, Pluto and Ceres. I pick on these because there are lots of dwarf planets, but these are the ones that any of us could see with a reasonable telescope. Pluto is in Sagittarius. It sets so soon after sunset that it's pretty much a hopeless case here. Ceres, on the other hand, is in Leo, and you'll see it in the morning. It's just under 9th magnitude, so a good pair of binoculars in a dark sky, you'll have no problem seeing it. With a telescope, I don't think you'll be able to see a disk. It's pretty small, but at least it won't be twinkling. It may have some kind of sign that it's not a star. So as always, I like to throw in a bit of deep sky stuff. You long-term observers, you've known this stuff, but if you're still new to the hobby and looking for exciting things to see, I'm going to point at the Perseus double cluster. Two open clusters right beside each other, kind of between the obvious asterisms for Cassiopeia and Perseus. Perseus has that kind of tripod shape, and then Cassiopeia is the W, and halfway in between them, there's that double cluster that you can just barely see with the naked eye. Looks even better with binoculars, and the more and more telescope power you throw at it, the more spectacular it gets. 869 is the NGC 869 is the younger of the two. NGC 885 has more red supergiants in it. It's a bit older. I just happen to have a picture of it here. The lower one is the older one. You can see some of the bright red stars in there. It's really quite a spectacular pair of clusters. Now, for the more experienced observers, I always like to find something more challenging. I would like to suggest, obviously, variable stars. KK Persei and XX Persei are stars associated with the cluster, both of them interesting variables. I would also suggest try taking images in both red and blue light. Try and see if there's a difference in the average color of the stars, and if you can estimate the cluster's ages from that. Well, yeah, all right, I'm going to admit it. Double cluster doesn't really have a lot to offer deeply experienced observer. So for you guys, I'm going to suggest Stefan's Quintet, a group of five apparently bound galaxies. Four of them are actually gravitationally bound together, and one more is just in the line of sight. You do need a biggish telescope to see it. My 8-inch telescope behind here is not good enough. I've never managed. Um, I've always managed it by taking myself up to Starfest or other star parties and looking around for someone with a big telescope who is willing to share. Um, you can look for halos around the galaxies. You can look for distortions in the galaxies caused by the gravity of the other members. So for you experienced observers, there's lots to see there. So we always have comets and meteors happening. The Orionids are the big meteor shower for the next month. Peaking around October 21st, we can probably expect 20 meteors an hour. It's not far off the it's not far off the full moon, so it's not going to be outstanding. No, it's not far off the new moon, so it is going to be outstanding. My apologies. Southern Taurids, they will peak November 5th, so that's into the next month's the sky this month. It'll be someone else's job to tell you about that. But they do start appearing on October 28th. So if you're out observing and you see meteors pointing back to the southern end of Taurus, you're probably looking at members of that shower. We have a minor shower, the Epsilon Geminids, going all month long. That's just a few meteors an hour. You won't notice it unless you just happen to be tracing back any meteors you see. And the same case for the meteor dribbles we've got there, the Draconids, the October Camelopardalids. I like saying that. October Zeta Perseids, very small meteor showers. You'd be lucky to see one in a night, but they are out there. So as long as you're out observing, keep an eye out for them. We've got some comets. C2017 K2 Pan-STARRS is the brightest one out there right now. It's in Lepus. It's going to be just a wee smidgen above the horizon, so either get yourself down to the north shore of Lake Erie and Point Pelee and look from there, or more realistically, if you're traveling further south from here, or if you happen to be joining us from Chile, you've got a good chance to look at the best current comet in the sky. C2022 P1 Neowise is 10.7 in Grus, and that's definitely southern hemisphere only. That's way below the horizon for us. And then a couple of ZTF comets, C2022 E3 and C2021 E3. One currently in Corona Borealis and the other in Antlia, and that's another southern hemisphere one only. But I noticed that we've got someone from Chile here in the chat room, so I'm hoping that they get a chance to go out and see these things that we can't. Now, according to space weather, yesterday, when I was putting the final touches on this presentation, there was a strong probability of auroral activity, not necessarily over Toronto, but at least more than usual. If you're out of the city, if you're in more northern parts of Ontario or anywhere closer to the magnetic pole, keep an eye out if it's clear. It might be a good night for aurora. And if you're deciding that you want to check sometime other than tonight and want to know what's happening, spaceweather.com is where I go for details and forecasts. So I don't know if Blake is here, but I always like to pick a double star, or in this case, a multiple star on his behalf. Iota Cassiopeiae, visible to the naked eye, 4.6 white A star. And it's a 7th magnitude companion yellow F star, the B star. With any reasonable small telescope, you should be able to split those apart. They're just about 7 arc seconds apart. Then there's a C star, which is another 7 arc seconds further away. It's considerably dimmer, and an orange K star. But triple stars, that's old news. We've seen stuff like that many times. So this one comes with 2 bonus stars that you are very unlikely to see unless you have a decent spectroscope. The A and C stars are both spectroscopic binaries. So if you're looking for a star that you can talk about at dinner parties, and all the people will be impressed by the fact that you've seen a quintuple star, this is the one to remember. Now, people who have listened to my talks before know that you're not going anywhere without hearing about a variable star. Our Aquarii is the one I've got this time. Varies between 5.2 and 12.4 magnitude. This is a cool one because it's a Z Andromedae type variable. And that means you've got a white dwarf and a red giant, and the white dwarf is slurping material off the extended atmosphere of the red giant. And every now and then, enough of it builds up on the surface of the white dwarf, and it will ignite, and the magnitude goes shooting up there, which is all very cool. I mean, these kind of cataclysmic variables are the kind of stars that are not getting caught by the automated star surveys. This is where amateur observers like you and I come in, because we're the ones that are seeing these phenomena happening within the early hours and getting the information directly to the professional astronomers who care. Now, this is even more exciting because not only is this a Z Andromedae type variable, but it's also an eclipsing binary, which is undergoing a once in 40 years eclipse. So this is all very fascinating, and professional astronomers are showing considerable interest in this. So the AAVSO, the American Association of Variable Star Observers, has set up a campaign along with astronomers using the Chandra X-ray Observatory in orbit to observe this and gather as much data as possible, which is where you and I come in. Any observations that you guys or I put in there will be put to work by professional astronomers and be a contributing factor in real life science. So if you get a chance, visual observations are great. If you have a photometer, even better. AAVSO.org is where you can go for all the details. And I hope somebody gets to get out there and get some really good science happening. So coming up in spaceflight, I'm actually not going to bother telling you about Falcon 9s anymore. That's old news. I could fill a page with them. It's interesting, but not exciting. It's not a highlight anymore. I mean, the big highlight is going to be the JWST, which is going to be sending us new stuff for years to come, but we're still in the early stages. New exciting stuff coming along all the time, so keep an eye out for it. I'm not going to ignore SpaceX entirely. Their Starship and Super Heavy orbital test is coming up, the exact date to be specified. And for dueling spaceships, NASA's Space Launch System and Artemis 1 also coming up at a date to be determined. I was hoping it was going to be sometime within the next month. The latest estimate I've heard is going to be early November, so we will see. The Mentian component of China's space station also to be launched, to be determined. Yeah, nothing's very specific this month, so you're going to have to glue yourself to your television as soon as you leave here and stick there until something gets launched. The ISS will be passing overhead in the mornings from October 19th until the next meeting. That's overhead here in Toronto. I've been looking at the space station for years, and I still get a kick out of it. It's It feels so much like the future seeing a space station fly overhead. For the exact times and locations, if you're not here in Toronto, heavensabove.com is the go-to for that information. But what if it's cloudy? Or what if your neighbor has brand new security lights and you can't see anything in the sky? Zooniverse.org has a heap of citizen science projects. There are dozens of them. The ones that I thought looked interesting this month: cloud spotting on Mars, disk detective looking for planetary disks around other stars, Rosetta Zoo analyzing data that's been churned down from the Comet 67P explorations, and dark energy explorers, because who doesn't like dark energy? Everyone's going to be up there looking at all these distant galaxies and looking for weird gravitational effects, and it could be you. So I hope you have a good month of observing, and thanks for listening.
Thank you, Andy, for a thorough review of the sky this month, as usual. Let's go to Ennio. Do we have any questions for Andy?
Yes, we do. But first, I'd like to draw attention to the very wide number of viewers watching this evening. We've got people from the west coast of Canada all the way to the UAE, so I'd like to extend yet another welcome to you.
Excellent. If there's someone here from the UAE, keep an eye out for that partial eclipse that we don't get to see from here.
Well, certainly. And I'd like to bring up Tarek Al-Manrani, who asks about recommendations for cameras to shoot planets. Telescopes are mostly known, but he's looking for any camera recommendations.
Oh, good question. I have to say the best images I've seen from planets over the past few years have been people using digital SLRs. I don't think the exact brand matters too much. The secret is to set it up on your telescope and take dozens or even hundreds of images, and then get your stacking software to jam them all together and get rid of the noise and get insanely detailed images that I never would have dreamt about in my youth.
Thank you. And that's our question for the evening.
Okay, cool. Thanks very much.
Okay, thanks, Ennio, and thanks again, Andy. Let's move on to our next speaker, Francois van Heerden. He'll talk to us about test driving the ToupTek 20 megapixel camera. Take it away, Francois.
Thank you very much, Paul. A great pleasure to be joining you tonight from Trenton, Ontario. Anyone who has met me or knows of me knows that I am a Malan-Cam user. I've used them for many years, but because I do a fair amount of outreach, and I was also looking for another camera that would allow me to do some more extra work. I wanted a 20 megapixel, and I wanted one that had additional functionality. So I'm going to take you on the test drive tonight that I did on the Gaspé. So I was actually out with a friend of mine near Saint-René-de-Matin. We spent a couple of days there, and I unfortunately got clouded out. But before that, I'd had a chance to do some imaging with this new camera. Let me take you and tell you why I got it. So let's start looking at the fact that if you are looking for an astro video camera, there's all kinds. And it can get extremely confusing. There's many choices for any budget. So you have the Malan-Cam, you have the ZWO ASI series, you have QHY. But one of the interesting factors is that many of these components for those cameras are built by ToupTek. So I started investigating them because price-wise, I figured I'd get a break. There are so many options, knowing what sensors to look at, knowing what number of pixels you want in those sensors. Do you want a color camera? Do you want a black and white? So a monochrome camera. The biggest thing that I looked at was, what do I really want to do? Do I want to capture lots of frames and post-process a lot of these, and that's in my future? This is what I'm now working towards. Or focus on outreach. And I wanted a camera that was sufficiently versatile to be able to do that. Give me quick views, let me see what I'm getting, and then be able to start detailed capture of the objects that I'm after. This takes a little bit of research. And if anyone ever wants any information, please feel free to reach out to me. I know people that use the ZWO and swear by them. They get phenomenal images, Dave Robitaille being one of these individuals, and another gentleman with him. But what you really want to look for is an industrial sensor versus the commercial grade sensors. This is critical because the industrial sensors can last far longer and handle a much wider range of temperatures. So look for anything that has an industrial grade sensor if you can. The next thing I want to do is, why did I choose ToupTek? Well, I wanted something that was budget friendly. Now that I'm retired, I don't have the wealth of money that I used to have while I was working. It had to be multi-purpose, as I mentioned. But the most important aspect that I was really looking for was thermoelectric cooling of the sensor. Why? If you use any of these sensors at normal temperatures, you will get amp glow at the edges. And this is something that you then have to edit out. By using thermoelectric cooling, you are reducing the sensitivity, or not the sensitivity, but the amount of noise, rather, from the camera sensor. And so you get a much smoother image across. So the first thing I did with my ToupTek when I got the 20 megapixel was use it indoors, and I ran it for 20 minutes. And I started to see after 20 minutes all of the warm pixels that you would expect in many sensors. Then I started to decrease the temperature. And by decreasing it every few minutes by 5 degrees centigrade, I took it down to minus 20, and I had a 100% flat background. Absolutely black, flat background. Perfect. This is what I was looking for. High quality components, ToupTek uses, and because they're right there where the technology is being manufactured, they get the best components that they can. Finally, I ordered online from AliExpress. Of course, I'm not flying out to China. Not going to happen, but I went online and started checking out the stores there. And from the time of order to delivery, and this was at the height of the lockdowns in the pandemic, was 4 weeks. I put in my order just before Christmas. The most important thing to recognize is that the label they put on the case actually shows that it was built 2 days after I put in my order. Then it was burned in for a full 24-hour period in the factory before it was packaged up and then finally shipped to me. This is the camera that I got. So there's the actual image that you're seeing here. And look at that price. If you look at ZWO, you look at Malincam for a 20 megapixel or 21, 22 megapixel, 26 megapixel, you're on the order of $3,000 US. This was $1,200 Canadian shipped. And yes, I paid $73 for DHL to ship it to me. But there were no taxes at the border. There was no duty. It came directly to my home. So here we go. On a limited budget, here was a perfect camera for me. When you get the package, it looks like this. You actually have this nice, robust case. It's beautifully sealed. Everything is laid out. There's just one deficiency in the camera or in the package that you get. The USB 3 cable is too short. You need to purchase a high quality USB 3 cable that is 15 feet long. And if you want to go a greater distance than that, then you must have an active repeater cable. So a powered active repeater cable. But they're not that expensive. You get one of those for 40, 50 bucks Canadian, and you're laughing. You're all the way to the bank there. The next thing is, let's take a look at what the actual sensor size. It is a full 1-inch diagonal. Extremely sensitive. I can do binning of 1 by 1, 2 by 2, 3 by 3, and even 4 by 4. I only ever work at binning 1 by 1, and on really faint objects, I will go to 2 by 2. But for the most part, you can see the scale here of the frames per second and the resolution I'm working at. And most of my images, until I actually start now doing more detailed work, are in the 15 to 30 second range. And I'm going to show you what these cameras are capable of and what the ToupTek is capable of. So what you're seeing here is ToupSky. This is the software you get with it. It's amazingly versatile, yet very easy to work with. You can start your settings in video mode, and then you go into the capture mode, the trigger mode, where you set the extended period of time that you want to expose the sensor to light. If you actually get close enough to look at this image, you'll see I was not perfectly in focus. But this is a 15-second image, and the core is overexposed. So I'm going to go through some of the settings that I actually use when I'm using ToupSky. So first of all, every image here is unretouched after the fact. I did not do any post-processing. I did not do filters. This is a single frame live from the camera into the computer, and that's it. So everyone is a 15-second exposure. I set my gain. So this improves the sensitivity of the actual sensor, the 1-inch sensor that's in it, at 20. I could go way higher. You never need to go higher than 20 for faint objects. My histogram, I adjust. 25 from the left, and I pull from the right back to 150. It gives me a nice balance. I do binning 1 by 1. As I say, no filters were used. The only thing that I will tell anyone that uses one of these cameras is find a darker spot in your frame where there's no stars, nothing bright. Make the smallest box you can there and do white balance on that. That is critical to you. Once you've set your white balance, now start to take your temperature down. I will frequently do the temperature ahead of time, take it down to minus 20 Celsius, and just let it sit there. Doesn't matter what the temperature is outside. The only caution for you is that when you are finished your observing run, start to move the temperature up incrementally in 5 degrees Celsius increments and let it stabilize for about 3 to 5 minutes and then repeat until you bring it up to ambient temperature. As I said, no post-processing. If you've been in meetings here and you've seen what the astrophotographers that are really competent do, they get phenomenal images. But this is live. This is what I do when I do outreach. So here's the first one for you to look at. Everyone is a single frame. M13. And you can actually see in that 20 seconds, if you look, you will actually see there is a little galaxy up here. That is the NGC 6207 galaxy that is in the same field of view as M13. This is in 15 seconds. With the sensor cooled down and with my settings set according to what I just presented earlier. When I actually run it through tools that will do identification of all the objects that are in the field of view, you'll see I even got IC 4617. So you are capable of getting some really faint objects. I should mention, Every one of these images was taken with a Celestron C8. That was it. From my backyard in Trenton. It's a Bortle 5 sky, so it's fairly light polluted, and I'm still getting this kind of quality. Here is the Ring Nebula, and notice that flat background across the entire back. Absolutely stunning. You're getting the color. It's visible. The stars here, I was in focus this time. It's nearly pinpoint. When you actually zoom in, because this is a 20 megapixel camera, you can actually enlarge this. You could definitely have it printed and stick it on your wall if you wanted to. More to the point, when you go after some of the really bright objects, let's take a look at the Dumbbell Nebula. This was the first frame that I took before I started adjusting some of the actual other settings to try and get more detail. So you'll notice that the stars, there was a slight tracking error in this particular instance. As I grabbed this frame, I let it stabilize a bit more. This was the next frame after I played it. It took me about 5 minutes to get this. And there's the detail. You're actually starting to get the lobes of M27, the Dumbbell Nebula. You get those colors. That is a live, single frame, unprocessed, unstacked. No filters. This is exactly what these cameras are capable of. Of course, you want to go after other objects as well. And Andy, your 8-inch, if you put one of these cameras on it, you will get Stephan's Quintet. I know I've done it with a 10 megapixel camera that wasn't cooled, and I was able to get Stephan's Quintet with my backyard set up with my 8-inch. So you might want to think about it for the future. M11, the Wild Duck Cluster, is stunning, as you can see here. Thousands of stars in the field of view. This one blew me away with the number of stars that are there. You can tell I haven't processed this because there's no color in the stars. They're all showing up as white. If I did post-processing and I did it correctly, I would end up with the stars actually showing their actual colors. But when you present this on a screen, when you're doing outreach, it's spectacular. M17, the Omega Nebula, and you can see the extent to which the nebulosity extends away from what you would see at the eyepiece. Absolutely incredible detail, 15 seconds. This is on the screen. So this is one of the objects that I fall in love with every year. I want to go and get images of it. Again, notice there's no color to the stars. So you are seeing exactly what the camera is seeing. I have a couple of more images for you. This one of the Andromeda system, M31, M32, and M110. You can actually start to see in 15 seconds, the core is just blown out on the Andromeda galaxy, and you're getting the dust lanes. This actually extends even further beyond. Now, I was actually using a hyperstar. So this was actually taken at f1.9. And this was overblown at 15 seconds. I actually took, this one is actually down at around 10 seconds that I got this detail on this frame. My final slide is probably one of the most spectacular galaxies. This was also taken with the same setup that I've described to you, M82. And again, I did not get the flat black that I wanted on the background, but then the sky isn't actually that way. But look at the detail you're getting in the arms of this particular object. M82 shows up, and with my Hyperstar, I get M81 and M82 in the same field of view. So the test drive, in my opinion, was a great success. This camera has exceeded my expectations with the, with the thermoelectric cooling in it. The sensitivity of the 20 megapixel is just far and away better than anything I have had in the past. And I hope this has been enlightening for you. And if there are any questions, I'm happy to entertain them.
Thank you, Francois, for the presentation and the overview. Sounds like a great camera. Ennio, do we have any questions for Francois?
We have several questions and a few comments. So first, I'd like to start with Tarek, who is joining us from Chile. And he says that he has a couple of ToupTek cameras, specifically the 26 megapixel cameras, the APS-C, and he's happy to know that others are using it. A first question outside of that would be for me. So if you are using a USB 3 repeater, would that introduce any noises into the signal?
Actually, no. With the USB 3, all it's doing is it's taking your signal and boosting it enough to go the extra distance. If you can actually gang two of them together, you can go 32 meters. So it does not introduce any noise, but I can then control the camera directly from indoors in my house. Right now, I run a network, and I would have done this live tonight, except that squirrels ate my network cable. Otherwise, I would have shown you one of these objects live with the camera tonight.
So Tarek also mentioned, Tarek, I apologize, also mentions that his first target was with the cameras was M5 and M13, and says that it was not bad at all. Sassy Photo asks, is this camera ASCOM supported?
ASCOM, absolutely. You can use this with any, the drivers come with the software, and it has everything you need. You can put it into any system, any computer system. It has the ASCOM drivers, so you can run it with, any of the other software out there. Absolutely.
Tarek also mentions that soon he will buy a filter, then we'll be able to use both cameras for more tests and results. Sassy Photo also asks, I presume you can do live stacking too?
Okay, so this camera not only does live stacking, it does live average or live additive. I never use live additive because after 5 or 6 stacks, it blows out the whole image. So you use average more than anything else. It will also do live dark and flat extraction from the live feed. But if you are saving images, it only saves exactly what comes from the sensor. So your image on the screen will be very pleasing using live average stacking, but you have an issue in that you're not getting the full value. But for outreach, yes, it does a phenomenal job.
Chris Vaughn asks, is there a difference between ToupSky and ToupView?
Not really. I've never used ToupView. I just used ToupSky.
Okay. Robert Lennox from Toronto asks if you were using an auto-guider.
No, none of these are auto-guided. I did my polar alignment using SharpCap, and I'm only 10 arc seconds off from absolute North Celestial Pole.
And I believe Guy Yanis asked if this is an IMX183C sensor.
Let me just go back in my presentation and I'll tell you exactly what it is because it was captured there. It is the IMX1883, yes, C.
Awesome, and that is all of our questions for now.
Thank you very much, everyone. I hope you enjoyed it.
Mm. Francois, I have a question myself. Is the camera being marketed as a long exposure deep sky camera or more for live viewing?
It's for both. You can literally, if you've got auto guiding, you can go for up to 5 minutes and no issues.
Okay. And the other question is that camera, the ToupTek, is it a clone of one of the better known brands?
As I said, Paul, ToupTek actually manufactures for ZWO
Uh-huh.
and QHY.
I see.
So it's basically the same guts. The only difference is, and in fact, ToupTek manufactures for Malincam, but Malincam has a couple of special circuits that Rock has designed that he puts in after the cameras get to Canadian shores. And then each one will only use their own branded software.
Mm-hmm. Okay. Wonderful. Great. Thank you so much, Francois. Very interesting presentation.
It's my pleasure.
All right, so let's move on to our next speaker, and that is Arushi Nath, and she'll speak to us about photometric observations of the Didymos asteroid system before the impact. Go ahead, Arushi.
Hi, everyone. It's great to be presenting again at the Royal Astronomical Society of Canada monthly meetings. So my name's Arushi Nath, and I'm a grade 8 student from here in Toronto. And as you all probably know, recently, around a week ago, the DART mission impacted the binary system Didymos. So today I'll be talking a bit about my own photometric observations of the system before the impact. So just a quick overview of the NASA's DART mission. The DART mission is a planetary defense test, which means, just to clarify, that neither Dimorphos, Didymos, or any other asteroid right now has a threat to hit the Earth. So the goal of this mission was to impact the Didymos binary system. So that includes the main asteroid, Didymos, which has a diameter of around 800 meters, and the moonlet, Dimorphos, which has a diameter of 140 meters. So the goal was to crash into the moonlet to change the orbital path of this asteroid. So it was able to successfully impact the moonlet, but this is not the only part of the mission. It has 3 other main steps. The first step is to cause around a 73 second change in the orbital period of the moonlet. Second, it's also essential that we get the binary period with an uncertainty of 7.3 seconds or less. And third, this is also a test to see how efficient the impact was, to see if in the future there's an actual asteroid that has a threat to impact the Earth, then we'll know exactly what size of impactor to send to the asteroid. So many people have been observing this asteroid, citizen scientists, of course, but also lots of professional observers from all around the world. For example, in Chile, there's the Atlas telescope, which is also in South Africa. And in Australia, there's the Las Cumbres Observatory Telescope. And but there's also citizen scientists who are also measuring the system. And citizen scientists are scientists who have either telescopes in their backyards, or maybe are getting proposals for limited time on other people's telescopes. So as you can see on the four pictures below, there's 3 main observations of the Didymos system. So first is the pre-impact observations, because it's very essential to get a baseline reading of the orbital period of the asteroid. The second is right after the impact, all the debris which is scattering around the asteroid, and it's forming tails. So while stacking the images, as you can see in the first 3 pictures, you can observe 3 tails coming from the asteroid. And finally, once all the debris has scattered, that's the actual test to measure if the orbital period of the asteroid system has changed. So how do we get measure the photometry of asteroids? So telescopes have a CCD camera attached to them, and this is receiving the light from the sky. And the more light it receives, the higher brightness a pixel becomes. And by combining all of these brightness pixels, we're able to get the total brightness of an object, in this case, Didymos. So now let me just show you a short animation of the Didymos binary system. So as you can see right here, the moonlet is going behind the main asteroid, which is why you can see a smaller dip right here. And now very soon, the moonlet is going to go in front of the asteroid as it just did, and that's where a bigger dip just happened. And this dip is also caused by the shadow which is coming on the asteroid. So with the asteroid light curves, they can reveal three main things about the mutual events of the two objects in the Didymos system. First, the primary occultation, which is when the moonlet, so the secondary object, is passing in front of the main asteroid. The secondary occultation is when the bigger object, Didymos, is passing in front of the moonlet. And finally, the primary eclipse is when the shadow of the moonlet is going in front of Didymos, and it's masking some part of the asteroid. But light curves can also reveal the orbital parameters of the asteroid. Especially in this case, this asteroid is not completely circular, and this is because the mass is not enough that it can keep heavy enough gravitational pull to keep the asteroid in a circular way. So just to show easier, I have an example of the asteroid. It's a potato, but let's assume it's the asteroid. So the light curve of the orbital period is caused when the asteroid is rotating around. So as you can see right now, only this part is visible. So that's when the dip in the light curve comes along. And now as the asteroid slowly rotates, more of the asteroid is visible, which means more of it is reflecting light, which means the brightness of the asteroid will go up. And similarly, when it goes back to facing like this, the light will go down again. And the orbital period of Didymos is 2.26 hours. So now I'm going to talk you through the 7 steps that I took to get the photometry of this asteroid. So the first step was getting images from the telescope. The second step was preprocessing and the data. Third was plate solving and aligning. Fourth was getting the aperture radius for both the COM stars and the target asteroid, sorry. Fifth was finding comparison stars that actually worked for my purposes. Sixth was removing phase angle and offsets, contributions, and finally was generating the light curves. So let's start off with my telescopes. So I've been able to get access to 5 telescopes located in Australia and Chile. And they have apertures ranging from 0.4 meters up to 2 meters. And to get access to these telescopes, I had to either write a proposal or get a membership, which gave me some limited amount of time on the telescopes. So to plan exactly when I would observe the telescopes, observe the asteroid, I've started taking observations since March 7th, actually. And to make sure Didymos is in my frame, I have been using some visibility calculators that are available, and that's to make sure that the air mass is low enough while I'm taking my observations. And also to create my observations, I had to input many informations, like my exposure time, the filters I wanted to use, the binning, and so on. And on the bottom right, you'll be able to see a small animation of one of my observations I got. This is on the 24th of September with a telescope located in Chile. So you can see here the asteroid is moving from the center of the image all the way to the far corner. So now step 2. So I was getting hundreds of images from these telescopes, and each image has a FITS header where it stores important metadata from the observation. So this could include stuff about the telescope specifications, like its focal length and aperture, also the observatory location, the time the observation was taken, and the exact coordinates that it was pointing to in the sky. And all these information is very useful when doing the further analysis of these images. So now let's go on to step 3, which is when I was plate solving my images. So lots of steps that I've done here can also be replicated in Python. I've shown an example here while plate solving, which is what I did in Python. For more information on how I did that, you can see my previous RASP presentation at the RASP General Assembly 2022. And that's how I talked about including plate solving and observation. So now let's go on to the 4th step. So this is selecting a good aperture radius for both the asteroid Didymos and the comparison stars. So I had to select different size apertures for both the target star and the comparison stars. And it was quite a challenge to actually get the correct size of the aperture because either if it's too small, then it won't cover the whole asteroid or the whole object. But if it's too big, then it'll also cover a lot of noise from the image. So I had to find the balance in between the two, which took a lot of trial and error. So step 5 was finding suitable comparison stars to use, because not all of them that were in the image I was actually able to use. Some examples of ones I was not able to use, you can see in the first graph here, right on the left. The magnitude is very scattered, and this is because the star was either too big or too small to be viewed in that aperture radius. In the second one, you can see that the brightness is changing over time for some reason. It could change, and then that means that it won't be a suitable comparison star. And then finally, you can see on the bottom left, this is a suitable comparison star because the magnitude is constant over the whole observation time. And if you look on the right, this figure here, I stuck it around 4 to 7 comparison stars each observation. And in this graph, you can see on the y-axis is the actual magnitude of these stars. And on the x-axis is the magnitude computed by the camera. So there's a blue line here, which signals the best comparison stars to use based on this to make sure that the actual magnitude is corresponding with the magnitude that the instrument detected. So I was getting a lot of observations of Didymos, lots of them on different nights. So while combining them, it was important to take in a couple things into account. One of them is the position phase angle, because the phase angle is basically the angle in between the sun, the asteroid, and the Earth. So since that is changing, the brightness of the Didymos asteroid will also be changing. And also, since the Didymos asteroid was coming towards us during this impact, it was getting brighter and brighter every day. So I had to take that into account, which is why I applied the phase angle and offsets to my data set. So in the first picture here, this is without any extra things added. And in the second figure, you can see this is where I've applied the phase angle and offset. And you will notice that they all seem much more aligned than in the first figure. So this comes to my final step. So this is actually generating the light curves of the Didymos system. So in the first graph, you can see this is one of my observations of about 1.8 hours. But as I said before, I was getting many nights of data, and that's where I combined them. So in the second figure, you can see both my observations combined. But 2 observations was not enough, which is why I've been working with 2 other astronomers, Daniel and Joaquin, And in total, we all got 6 observations. And combining all these observations together, I was able to get a light curve of 2.599 hours. And the expected light curve is 2.6 hours. So that was very accurate. And I was also able to get an amplitude of around 0.114. And this was great because with 1 week of data, 6 days, we were able to get a pretty accurate light curve. A couple of days ago, I found about this source, which gave me all the mutual events of the Didymos system. So you can see them here. In black is the ones before the impact, and in red are the ones after the dark mission impact. So I hadn't noticed it before, but one of the observations actually fell in line with one of the mutual events, which is why in this figure here, you can see the 7th observation right here in blue is going slightly, is not lining exactly with the other observations. And this is because of the change, because we were experiencing one of the mutual events. And this is also why after aligning it with the orbital period, they were all able to come together. So since the orbital period of this asteroid is very huge, 12 hours, and our observations are limited to 3 or 4 hours, it's very important to time the observations to get these type of impacts. Professionals with bigger telescopes definitely won't have any problem getting these impacts. As you can see in the bottom, they're able to get all 3 mutual all 3 mutual events, the primary and secondary occultation, as well as the primary eclipse. One more thing I wanted to share is I've also been getting data from the NEOSat satellite, and this data, so NEOSat is actually our own Canadian space telescope, so it's rotating the Earth constantly, and I was able to get my first set of 30 images. Unfortunately, the SNR, or signal to noise ratio, I was getting is very low, about 15, while the expected or the desired is 100. So in the future, I'll be increasing exposure times and changing different factors to be able to get a higher SNR and use this information. Also, the pixel scale is 3 arc seconds per pixel, while the other telescopes I was using normally had around a 0.3 arc seconds per pixel, which gives much better results. But again, by adjusting configuration settings, I will still be able to use the NEOSat telescope to get further observations. And like all my other projects, I always publish my data open source. So I've published my data on the AlcDef database, and here it'll basically all the other previous observations of Didymos from the AlcDef database was before very long time ago, at around 2003. So I'll be adding my more recent observations to make the database, improve the database. And I'll also plan to submit my observations to the DART observing group, but they have very strict guidelines. For example, we need 6 hours of observations, and the RMS should be less than 0.01 magnitude. And they have also rules on the exposure time to use and filters and so on. I would also like to acknowledge people who have helped me with my project. For example, Christina Thomas, who is a project lead in the DART mission, and she, through Zoom calls, has been helping me learn more about the DART mission and about configuration settings to use. Also, Christian and his team from iTelescope, along with many other people who have helped me get observations or analyze my observations, or even give me advice on what filters and so on to use. I'm continuing my observations to post-impact. So if anyone has any telescopes, or you're part of any organization that has any telescopes, I'd be really grateful if I could get some observing time on them so that I can continue my observations. I'll also be presenting at the next Rural RAS meeting next month to talk about my post-impact observations of this asteroid system. So feel free to tune in if you found this presentation interesting. It was great presenting, and I'll be happy to answer any questions if there's any.
Thank you, Arushi, for an amazing project that you shared with us, and congratulations on the results you obtained. Very, very accurate. Well done. We look forward to the next presentation next month. Anya, do we have any questions for Arushi?
Yes, we do. And firstly, I'd like to say, really cool. I definitely want to rewatch this tomorrow and over the weekend. Our first comment is from Eric Briggs, who says, "Great light curve." My question is if any of your steps in how you created this work is available via Jupyter Notebook.
That's a great question. While some of the parts of my project I've been experimenting using Python, most of my analysis was carried out through a software called ToupTek. So it's a relatively cheaper software, which I found was very useful because I was able to perform all of my steps on it, and it's also a regularly updated software.
Cool. Our next photo is from Sassy Photo. I apologize. Our next question is from Sassy Photo. When combining data with others, did you use the same filter? I'm asking because the phase angle scattering can be different with different filters.
That's definitely a great question, which is why all observations were analyzed separately. So yes, some of them were taken through different filters, which is why all of the offsets and applying data was done separately for each observation before combining them together, so that it would all match with the filters and other configuration settings set for that specific observation.
Fantastic. Sassy Photo also says, "Bravo, Arushi. And thank you for your amazing presentation."
Thanks.
And that's all we have.
Good. Thank you, Anya. And thanks again, Arushi. And we'll see you next month. That concludes the speakers lineup for this evening. Let's go to Tom Luton with the announcements for tonight.
All right. Well, thank you very much, and good evening, everybody. Well, I've got to admit the announcements are not exactly going to be as exciting as Arushi's presentation, but I'll see what I can do. So we have two types of meetings here online on YouTube. You've just had one of our recreational astronomy nights, and we're going to have a speakers night coming up in 2 weeks. For those of you who are joining us live on YouTube, please say hello in the chat and enter some questions for presenters, as others have done already tonight. If you're a new member, please introduce yourself. And like some of the folks have been doing this evening, if you're coming to us from far, far outside of Southern Ontario, please let us know where you're from. And incidentally, I'm speaking to you tonight from Cobourg, Ontario. So our next speakers night is Wednesday, the 19th of October, 7:30 p.m. Jepavu Jabba Adams from York University will be discussing Always Looking, Always Learning, from amateur astronomy to computing and back again, here live on YouTube. Our next recreational astronomy night is on the 2nd of November, 7:30 p.m. Arnold Brody with The Sky This Month, Frank Dempsey with Frank's recent Merry-Go-Round Observatory project, and as Arushi already mentioned, part 2 of her talk, photographic observations of Didymos asteroid system after the impact, using robotic telescopes, open datasets, and maths. If you've got something you'd like to present, please contact Paul Markov. Coming up with the DDO in the next little while, on Friday, October the 7th at 7:30 p.m. is DDO Up in the Sky. With a $12.76 registration fee, links to the event can be found at rascto.ca. DDO Astronomy Speakers Night on Friday, October 14th, 7:30 to 9 p.m. Julie Clavo will be talking about Canada's role in the James Webb Space Telescope mission. $12.76 fee. And again, registration links can be found at raskto.ca. Sunday sun gazing on October 16th at 12:30 p.m. to 1 p.m. $6.92 registration fee. Again, links at raskto.ca. Observing sessions coming up. We've just concluded the observing sessions for the first part of October. And so our next City Star Party is Bayview Village Park on the first clear night of the week of October 31st to November 3rd. Remember, first clear night. There will be a go, no-go call put out put out that evening when we make the decision as to whether or not the weather is going to behave itself. We're going to be looking at starting up. We're still trying to set up our dark sky star parties. I'm sorry, folks. I'm just stumbling over my tongue tonight. Now, effective the 1st of October, Toronto Council has restarted most indoor events for the RASC. We're recommending volunteers and visitors wear masks, but it's not mandatory. And when deciding whether or not to participate in outdoor or indoor events, all members should consider their personal health and comfort first. So what this means is that DDO and EPO indoor events can go ahead. Telescope loan program is going to restart at a date in the not so distant future. What's going on is they're currently undergoing some equipment maintenance, and as soon as that's complete, they'll let us know, and you'll be able to borrow telescopes again. Meetings at the Science Center will resume as soon as they let us back in, and after the AV committee has had a chance to check over our equipment and have at least one rehearsal beforehand. Now, the delay with the Science Center has to do with the current construction that's going on. In fact, in a world when COVID did not happen, it's very likely we would have been homeless for a portion of 2022. Anyway, what's going on is that the bridge that connects the rest of the Science Center with the main entrance is down for repairs. And what this means is that our normal meeting room, Studio 2, is, instead of being a short distance from the main entrance, is now a very long walk from the backup entrance that the Science Center is using, which is down at the bottom of the valley. They're using their security entrance now as their main entrance. This longer walk also means that you'd have people walking through the exhibits after hours, and the Science Center is obviously does not want that happening. We are trying to arrange things, hopefully for use of the Gemini room coming up. We'll keep you posted. We want to get these meetings back to in person as much as you do. The CAO is the exception to all of this because it's our facility and because it's a place where people are staying overnight. We're being a little more cautious. Updated guidelines will be coming soon from the committee. But for the moment, access to CAO facilities are by members and families only in a modified communal fashion, with the total site occupancy limited to 25 individuals. The upstairs washroom is only for upstairs bookings, with max occupancy for the upstairs bedrooms, 2 people from the same family per bedroom for a total of 6 people upstairs. Communal area is limited to 3 people with masks. All CAO users can use both kitchens, downstairs washroom with masks. Full details are on the website. Please read before you make your bookings. Okay, so our job board. We're looking to fill a few roles. First of all, I'd like to publicly acknowledge and thank Ian Wheelband for his long-standing work as Education and Public Outreach Chair. Ian has stepped down, and we have been trying to fill that role for a little while now with no success. We're looking for an Education and Public Outreach Chair. So I've asked some people, and who, if you've already said no to me before, but if you're sort of thinking, yeah, maybe, please drop me a note. Or if I haven't spoken to you and you think, hey, sounds interesting for any of the positions, drop me a note at president@raxto.ca. So in addition to the EPO chair, we're looking for a light pollution committee chair, a volunteer committee chair, and a marketing committee chair and some committee members. The AV committee, the folks who work so hard to put this presentation together, are always looking for help. The EPO committee itself is always looking for additional members, especially for online presentations, and as well for telescope camera operators for any virtual star parties that will be going forward. Just a reminder that to be a volunteer, you first must be a member of the Toronto Centre. Just a reminder about RASC membership. You can renew online at secure.rasc.ca. There is a RASC emergency fund if you're running into some financial difficulties, and as well, gift memberships are available. From all those details, contact the national office at mempub@rasc.ca. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. You can follow us on all the forms of social media we've got listed here. If you're watching us live on YouTube and you like what you saw, please like and subscribe and click the notification bell. Be safe. Keep looking up. Good night, everybody.